Hello, everyone. Welcome back. Yesterday, we talked about what an angle bisector is and what a perpendicular bisector is. Today, we're going to focus on something called concurrent lines. So, concurrent lines are when three or more lines intersect at the same point. So, if I over here draw this red line, this purple line, and then this green line, these three lines are concurrent because they all intersect at this blue point. Oops, I'm still on line. And this blue point. Oops, it's not blue, it's red. Come on. All right, brought it back at this blue point here, which is the point of concurrency. So that's what concurrent means. So now for our first example here, what I want us to do is I want you to pause and I want you to plot those 3 points. Okay, so there I plotted the 3 points. I'm going to connect them. It's supposed to make a triangle. Now what I want to do is I want to find the midpoint. So I'm going to start by finding the midpoint at AC. Now remember, to find the midpoint, I use the midpoint formula, which is x1 plus x2 over 2, comma y1 plus y2 over 2. So when I'm doing AC, I'm doing 1 plus 7 over 2, comma 3 plus negative 1 over 2, which works out to be 4, because 1 plus 7 is 8, divided by 2 is 4, comma 1. 3 plus negative 1 is 2, divided by 1. And let's name that point M. So I'm going to plot that on my graph at 4, 1. And that's M. So now I want you to pause, and I want you to find the midpoint of BC and the midpoint of AB. And we can name them MLV. We'll use my initials. Okay, so the midpoint of BC, I called L, which is the point 82. The midpoint of AB, which I called V, is the point 54. Now we want to find the slope of all the lines of our original triangle. So remember, slope is the y2 minus y1 over x2 minus x1. So when I'm finding the slope of AC, I'm going to do 3 minus negative 1 over 1 minus 7, because I subtract the y's over subtract the x's. 3 minus negative 1 is 4. 1 minus 7 is negative 6. That can be reduced to negative 2/3. Now we got to remember what the perpendicular line. Perpendicular slopes are negative reciprocals. So that means negative 2/3 is 3/2. So again, I'm going to find the slope of BC this time. So I subtract the y's. I'm going to do 5 minus negative 1. Always have to go in order. Over 9 minus 7. 5 minus negative 1 is 6. 9 minus 7 is 2. So that's 3 over 1. So the perpendicular slope is the negative reciprocal, which is negative 1/3. I want you to pause, and I want you to find the slope of AB and identify what the negative reciprocal slope is, or the perpendicular slope. Okay, so the slope of AB is 1/4, and therefore the perpendicular slope is negative 4 over 1. Now our directions are to draw the lines that are perpendicular that pass through the midpoint. This is the perpendicular bisector. So using the slope, I'm going to start at the midpoint. So first I'm going to do AC. So the perpendicular slope of AC is going to go through the midpoint of AC, which is M. So I'm going to start at M, and I'm going to do the slope of 3 over 2. So I'm going to go up 3 over 2. Do that again, up 3 over 2. So there are my lines, my point, and I'm going to make this line purple. And there's the line that is the perpendicular bisector of AC. Now I need to do the perpendicular bisector of BC. So it's going to go through the point L and have a slope of negative 1/3. So we start on L and we go down 1, right 3. Now that's taking me away from the other line, so I'm going to do the opposite. So I'm going to go up 1, left 3. Up 1, left 3. Then I'm going to draw a line connecting those. I'm going to make this line red. So the red line is the perpendicular bisector of BC. Now last, I'm going to do the perpendicular bisector of AB. So that's going to go through point V and have a slope of negative 4. So I start on V, I go down 4, right 1. Down 4, right 1. And I'm going to draw a line connecting those, and I'm going to make this line be blue. No, not blue, because we already used blue for the triangle. Pink. So the pink line is the perpendicular bisector of BA. And you can see that all three of those points intersect, all three of those lines intersect here in the middle. That is my point of concurrency, which is going to be called the circumcenter. So, are the lines concurrent? Yes, because they meet at a single point. Theorem. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices of the triangle. This point is called the circumcenter. And what we mean by equidistant is if we scroll back here and look at our triangle, if I were to draw the lines, and I'm going to draw them in black, if I were to draw the line from M to B, M to C, or not M, that point, because that's not M, and that point to A, all those black lines that I just drew are all equal. And that's our theorem. So now we want to find the circumcenter of triangle big. So I want you to pause, and I want you to plot these points. Okay, so there's my triangle big. Now we want to find the circumcenter. So our directions say to construct, but we haven't learned how to do constructions yet. So we're not going to actually do that part. But we're going to find the circumcenter by the circumcenters where the perpendicular bisectors meet. Now we already know that the perpendicular bisectors all meet at one point. Therefore, we only need to find 2. So the first perpendicular bisector I'm going to find is of BG. And why I'm picking BG is because it's a horizontal line. Lines that are perpendicular to a horizontal line are vertical. So that means I really only need to find the midpoint. So I can find the midpoint of BG by doing the formula. So I'm going to do 5 because the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. So I'm going to do 5 plus negative 5 over 2 and 5 plus 5 over 2, which gives me the point 0, 5. So my perpendicular bisector of BG is actually my y-axis. It's that red line there that I made. Now I'm going to find the perpendicular bisector of BI. And again, I'm doing BI because that's vertical. So the slope, the line that's perpendicular to a vertical line, is a horizontal line. So the midpoint of BI, I'm going to do 5 plus 5 over 2, comma 5 plus negative 1 over 2. And that gives me 5, comma 2. So this pink line is my perpendicular bisector. You will notice that these intersect right here at the point 0, 2. So my circumcenter is 0, 2. Now, what we were kind of starting to talk about with our construction, which again, we're not doing constructions right now, is the idea that if I drew a circle, so if I did a circle so that that was the center, to do a circle, how I do a circle on graph paper is I count equal distance from the point. And if I were to graph that circle, it would touch the vertices of my triangle. So the circle, that if I drew it around my triangle, I cannot draw it very well. So let's forget drawing it. A circle containing the triangle whose vertices is circumscribed about. So what that means is that if I draw the circle around the triangle, it's going to touch the vertice. And this is important because this tells me that the circumcenter is equidistant from all the vertices. Okay, and that's the end of our video for today. If you have any questions, please ask them in class.